Challenge to make a DIY machine frame that no one has ever done before. Using new ideas to solve structural problems. A really beautiful formwork was created. Hi guys. This DIY 5-axis CNC machine project is now part 7. Due to new ideas that came up during the process, the actual fabrication was delayed due to testing carbon fiber epoxy granite and redesigning the A and C axes. It took a long time from the time I built this spindle unit until I could move on to the next process. But I believe that what is more important than completing a machine quickly is to make a machine that is extremely attractive. The machine that is attractive to me is also attractive to you. It is not a run-of-the-mill design, but one that contains a lot of innovation. Whether I fail or succeed, it will stimulate your imagination. And then I can gain experience too. Now let me explain the contents of this video. 1. The fabrication of the saddle portion of this machine. The important point in fabricating the saddle is to make an epoxy granite frame with high accuracy. Since the Y-axis frame of this machine is mounted on the ground, this means that the main frame of this machine is the Y-axis frame. The X-axis is on top of the Y-axis. And the Z-axis is on top of the X-axis. This means that the saddle must be fabricated so that the linear guides in the X and Y directions are accurately installed. If epoxy granite is poured and hardened with poor accuracy, it is very difficult to correct. Of course, accuracy can easily be achieved by machining the entire saddle section on a milling machine. However, most people do not have such equipment. Therefore, it is necessary to make the saddle part as highly accurate as possible. 2. Countermeasures for structural problems. Actually, this type of machine has a problem that the load on the Y-axis movement in the plus direction is large. And countermeasures are necessary. As I mentioned before, this machine has the saddle on the Y-axis. The saddle itself is large and heavy. The headstock unit, spindle motor, stepper motor, etc. are mounted on top of it. Of course, the X-axis is heavy, so it is going to fall down. In other words, there is no problem in the minus direction, but there is a possibility of insufficient force in the plus direction. This was the case with the 5-axis machine I built last time. The Y-axis was heavy, and it sometimes had not enough force for machining in the plus direction. Therefore, this time, I added this countermeasure from the design stage. This countermeasure is also a new idea and will be interesting for you. 3. Formwork creation. Carbon fiber plates are used to make the formwork for pouring the epoxy granite. This formwork will be integrated with the epoxy granite. It is important to be able to make this formwork with a high accuracy. Making a cool machine is important to satisfy myself and you. Now, let's start the making process. First of all, I will use an aluminum plate as a base for mounting the linear guides and ball screws. Temporarily assemble the linear guide and decide the screw hole position so that the linear guide can be installed in the correct position. The 5mm aluminum plate is full of holes. These include linear guides, linear blocks, ball screws, and screw holes for fixing epoxy granite. The 5mm aluminum plate is so thin that it is deformed. Fix it with the 8mm plate of the spindle unit and the linear guide of the X-axis to correct it. Before it is all cemented together with epoxy granite, make sure that the linear guides in the X and Y axes can be adjusted. At this stage, this is a temporary adjustment. This level of adjustment should be sufficient. Shears. Saddle unit weight countermeasure. The machine I built last time had several problems. One of the problems was that the saddle unit was too heavy, causing the stepper motor on the Y-axis to step out of alignment. A support is needed to lift the heavy saddle unit, which has many parts such as the headstock unit and stepper motor attached. Counterweights are often installed on machines that are designed to lift heavy objects. This is a method of reducing the load by placing a weight on the opposite side of the part to which the load is applied. Counterweights are suitable for lifting with the same force no matter where the Y-axis is located. But using a counterweight increases the overall weight of the machine and also increases the machine size. As I focus on weight reduction and downsizing, I do not want to use this method. So I came up with the idea of spiral springs. By using this to wind up the wire attached to the column, the saddle unit is always lifted. This way, the weight of the machine will not change much. I don't know if it will work, but I'll give it a try anyway. Oh my God. I don't know the strength of the springs, so I bought two kinds for now. Now that the frame and shaft are ready, the spiral coil is assembled. Something's wrong. The spiral spring is something is wrong. Oh my God. The coil has spread. How do I put it back up again? I looked it up on the internet and found that it can be fixed by wrapping the spring from the outside, so I will try that. Fixed it. It was very painful on my fingers. I need to take measures to prevent the spiral spring from shifting. Also, I should probably remove the tie holding the spring in place after all the work is done. Maybe I don't need to remove it. Now, let's test it. It is completed. I installed the weaker spring, but the spring still seems to be too strong. I think it needs to be adjusted when actually installing it. I am going to make the formwork for the epoxy granite. I will make that formwork out of lightweight, tensile strength carbon fiber and integrate it with the epoxy granite. I will create a beautiful carbon fiber look and lightweight, high strength machine base at home. Many people know about carbon fiber, but few know about its processing. I will show you how I process carbon fiber to make my formwork. Please enjoy. Forgot to put on gloves. I'm much more tired than I thought I would be. I'm going to take a break. I am now going to assemble the carbon fiber plates. If the formwork is done well, the final shape should be beautiful. The issue is where to pour the epoxy granite from. At this stage, I still hadn't decided where to pour the epoxy granite from. The general shape of the frame has been created. There is still more work to be done, but the video is getting long, so this is all for now. You may be interested in how I poured the epoxy granite. I have come up with several methods. In the next video, I will be pouring the epoxy granite and then making the modifications, and so on. I am looking forward to seeing how good the final quality will be. Actually, I have already poured the epoxy granite. And I made a stupid mistake. I did something really stupid. I want to be a person who is not afraid to try and fail, but hopefully I will learn from watching others fail and not fail myself. People and their failures are instructive and funny. You can look at my failures and laugh too. I encourage you to subscribe to my channel to laugh at my failures so you don't miss my next video. If you empathize with my project, why don't you become a member and support this channel? There are few benefits, but as long as you are a member, your name will appear at the end of the videos as a patron. In other words, you can be a part of this project. So, please look forward to the next video.